Welcome back, everyone. In this lecture, we're going to give you an overview of the project for this section of the course, which is using TensorFlow 2.0 Keras API to perform a classification task. Now, this is one of the largest projects in the entire course, so let's go ahead and take the time to actually do an overview of what's in the notebook. All right, so if you open up the folder that contains our ANN notebooks and scroll down, you'll see two project-related notebooks. The first one is Keras Project Exercise, and then the next one is Keras Project Exercise Solutions. Right now, we're just going to give you an overview of the actual exercise notebook, and then coming up through the next series of lectures, we'll be walking you through the solutions. So go ahead and open up the Keras Project Exercise, and we're going to be using a subset of a lending club dataset obtained from Kaggle. And you can check out the link here, but keep in mind, we recommend that you don't download the full zip file that's actually from this link. We provide a special version of this file that actually has some extra feature engineering for you to do. So we've added some extra features for you to then use to get practice on feature engineering and working with realistic looking data. So this is real data, and we've actually added more information to a subset of it. Okay, so Lending Club, if you're not familiar with it, it's basically a US peer-to-peer lending company. It's headquartered in San Francisco, California. And what it does is it gives out loans to people, and then they have to pay back that loan with a certain interest rate. And sometimes people won't pay off that loan, and the company is going to have to record that as what's known as a charge-off. Essentially, they have to write off the loan because it wasn't paid back to them. So the loan status column will contain our label for this particular class. And we're going to try to predict, based off historical data and the features of a potential customer or potential borrower, whether or not they will default on the loan. So default is known as a charge-off, or will they fully pay back the loan, fully paid. So keep in mind the classification metrics that you're going to be evaluating when evaluating the performance of your model. So the couple of first cells have already been filled in for you. And since there are actually many Lending Club datasets on Kaggle, we have information on this particular dataset filled out for you in a table here in this cell. So you can go ahead and check out the various features. So for instance, int_rate, here's a description of it. It's the interest rate on the loan. So we have the descriptions for the various features that are included in this data set. You'll notice it's quite a large data set with many interesting features. So we're going to spend a lot of time visualizing and doing exploratory data analysis, as well as performing basic feature engineering. And we've filled out just a little bit of starter code for you to read in the file, as well as a little feat_info. So you'll notice that we actually have this table, and what we did is we built a little function for you called feat_info, which will print out feature information based off the string column you give it. So for example, if you saw the string column mort_acc, then you could just pass that into this built-in feat_info, and it would print back out for you what the actual description is, which is number of mortgage accounts. So go ahead and run these first couple of cells. It'll read in the file for you, and it'll also create this informational function call. And then down here, we will be reading in the actual data for you, and then it looks something like this. Notice that there will be missing data that you will have to deal with, and we essentially guide you along with this project. So then we actually reach the project tasks section. And so section 1 is exploratory data analysis, and we'll just ask you to be creating some of these visualizations. And keep in mind, you may need to actually Google around, and we provide helpful links on certain tasks that we may not have specifically gone over, but you should be able to do them given what we've gone over in the data visualization crash course section. So for example, we have a heat map for you to build out, and in case you need any help with that, we have links here for heat map information, help with resizing, etc. You can continue scrolling down. I want you to create some scatter plots, some box plots. Then we want you to actually follow the instructions to build out a little bit of some bar plots here that are hued based off the loan status, whether it's fully paid or charged off. And there's descriptions here on what you can do. And then we want you to create a bar plot per category, maybe start resizing it so it looks something like this. You can change the color palettes as well, and etc. So we basically have various plots for you to kind of play around with. And if we scroll down, the next section is data pre-processing. And this has a little less to do with actually visualizing the data. And really our goal here is to, 1, remove or fill any missing data. We want to remove unnecessary or repetitive features, and then we want to convert categorical string features to dummy variables. So this is where we're going to be doing a lot of feature engineering and feature analysis. So we'll first deal with the missing data, and we have instructions here on for you to kind of follow along and how to deal with that missing data. And then after that, we'll kind of examine the missing data, see what we can keep, what we should fill in, what we should drop. And then we'll also start dealing with categorical data. So if we start coming down here, we start dealing with categorical data, and we also have some challenge tasks for you to follow along with. And then down here, we keep dealing with kind of feature by feature basis, etc. And eventually, after dealing with all this feature engineering, you should be ready for a train test split. If you get stuck on any of the feature engineering tasks that we try to lay out for you above this train test split line, go ahead and refer to our solutions notebook. And keep in mind, you can actually just take this data set and try to build a model on your own without necessarily following along with our exact steps that we've laid out here. The main goal of this is to build a model that attempts to predict the actual label class. It's just a binary classification. So you perform your train test split, and then optionally you can grab a sample for training time. So the sample contains about 395,000 entries. If you're dealing with a smaller RAM computer or something that's not GPU, we have a little sample code here to take a fraction of the data set to train on. Okay, so after you perform your train test split, you want to normalize the data. Then you create your model. We have some imports for you here. You can create whatever model you feel necessary, but we recommend, or the solution actually uses 78 neurons to 39 neurons to 19 neurons to 1 neuron. This is totally optional. You essentially have unlimited options. You can mess around with adding in dropout layers, etc., and we have links for you here to check out as well. So I would recommend adding in some dropout layers, and in the solutions notebook, you can check that out as well. We have this particular network structure with 0.2 or 20% dropout for each of those layers to try to prevent overfitting. Then we want you to fit that model for at least 25 epochs, and then you'll keep going here, save the model, evaluate your model performance, see these plots, just as we've been doing, and then finally, given this customer below, would you offer this person a loan? Okay, so then you can check against the results, and that's the project. Thanks, and we'll see you at the next series of lectures where we'll be eventually working out through this solutions notebook. If you get stuck anywhere in this project exercise, go ahead and just refer to the solutions notebook that's already filled out for you. I'll see you there.